Hello, we're Chemical Engineering Group 2 for Metals Recovery. My name is Wyatt Haig. My group mates are Samantha Thompson, Jose Regalado, and Adam Jorgensen. Our problem statement for this project is to identify valuable non-copper metal byproducts from recirculated sulfuric acid leach solution at Phoenix Mine. Once one or more of these products is identified, a recovery process was researched and designed. This should be net positive economically and environmentally friendly. ICP analysis showed high concentrations of zinc, aluminum, magnesium, and iron. Aluminum, magnesium, and iron are waste metals with no economic value, so the target metal was zinc. The two proposed processes are ion exchange membranes and solvent extraction.
Between these two processes, we found that ion exchange is not feasible. This is because it's better suited for lower concentrations of zinc, and the stream that we're dealing with specifically is considered high concentrations of zinc. Also, ion exchange has high initial costs and operational costs. Solvent extraction, on the other hand, is better suited for the concentration of zinc that we have in our stream, and it has lower operational costs. The only caveat is it does have higher costs associated with pH changes within the system. This is our finalized process design. As you can see, it's a complete recycle stream. We take from the raffinate tank and we put it through our solvent extraction. It then goes to electrowinning to remove the zinc into a sellable form, and then it recycles back through to repeat that process again. This aligns with our core objective 14 classes, notably mass and energy balances, chemical engineering, thermodynamics, process design, electrochemistry, separation methods, and engineering communication.
Now I'm going to go over the application of our ABET criteria. So first we have our public health. Public health criteria pertains to making our process safe and healthy overall for everything involved. We have our safety criteria. Our process needs to be safe again. We have our welfare criteria. Our process can't interfere with any other parts of our plant. Our global and cultural impact. Zinc is in very high demand globally. Our environmental impacts. This process needs to be positive for the environment. And our economic impact. This process needs to have positive impact on the economic gain of the Phoenix Mine. Next, we're going to go over our ABET Incorporation of Engineering Standards. So our process follows standards set forth by OSHA, NFPA, MSHA, and several other engineering organizations. So first, we have our materials standards. These pertain to materials of construction. Then we have our process piping code. This again pertains to materials, but specifically in piping. Then we have our Title 30. This is miner safety. Then we have our NFPA Title 30. These are standards for hazardous compounds. And then we have our OSHA 1910, which gives guidelines for HAZOPs, SOPs, and maintenance.
For our solvent extraction process, several constraints had to be met. The bleach stream could not exceed 5,000 gallons per minute, and the recycled raffinate had to return a pH of 2.2. Zinc concentration was limited to 2.891 grams per liter. We also needed 12 minutes of residence time for extraction and 30 to 60 minutes for electrowinning. All this had to comply with the engineering standards we had just previously discussed. And then in conclusion, our design demonstrates a complete process solution. It incorporates skills from our core classes, it meets ABET criteria, and it addresses key factors like public health, environmental impact, and economic viability. Thank you.